Warm up for lesson 3-5 operations with matrices. Take a minute to pause and try the problem. And here's the answer. Pause and try the problem. And here's the answer. Pause and try the problem. And here's the answer. 3-5 operations with matrices. Objective: analyze data in matrices and perform algebraic operations with matrices. Okay, a matrix is actually an array of numbers. The numbers are in positions that we call an element. So each one of these is an element that represents something. All of these elements represent tuition. All of these elements represent room and board for the different universities. And then here is the enrollment. When you have an array of numbers, you can utilize these numbers and find some information out. For instance, you could take the first three numbers in the first column because they represent tuition, and you can add them up divided by 3 to get an average tuition cost. We can also add and subtract matrices because they're numbers and we have operations with them. So for example, we can take this first element and the element in the same position, add them up, and we will get the answer 5. And we can do the same thing with this element and this element. They're in the same position, and so we can come up with the number -5. Take this number and this number, those two elements, add them up, and that'll be -8. And then these two that are in the same position, add those elements, and that'll be 17. And this is what we call adding matrices. Let's do it again. I want to add matrix A and matrix B. So what we're going to do is we're going to add the elements in the same position. You can skip this step and go right into here. Then we're going to add these two, and if you want to do it in your head, you can. And the same with these. We'll get -1 and 0 and 3 and get 3. And that is called adding matrices. Pause and see if you can do the problem. If you had trouble with part A, it's probably because it's not possible. What's happening is the matrix doesn't have the same number of rows and columns. So we don't have the element here does not match one element over here. So we can't really do any adding. Part B, we did match and we're able to match that up and get our answer. Okay, so let's go ahead and multiply a matrix by what we call a scalar. And when you do this, you multiply each individual element by the value of the scalar. For example, if you're multiplying by -3, you're going to multiply each one by -3. This is a distributive process. And so the answer, again, you can go ahead and skip this middle step and just write -12, -3, -21, and +12. If you want to skip this middle step, that's fine. All right, let's go ahead and take a look at another example. Again, we're going to multiply by 5, and again, it's a distributing idea, and you're just going to multiply each one, and you can go right to here and find out all the answers. Let's go ahead and try to find -4t. So I'm going to take my t right here, and I'm going to multiply by -4 each time. So that'll be -32, 0, -12, and then +8. Now I'm going to multiply -4 by that one. That'll be 4, +16, +8, and then -36. And this is the answer when you multiply by a scalar. Pause and see what you can do. And here's the answer. Now there are the properties of matrices. The commutative property, which says that you can add two matrices in one order and then reverse the order and you'll get the same answer. The associative property, you can add two matrices first, add the third, or add the second and third and then the first. And we just covered the distributive process. There is a left scalar and a right scalar, so you can multiply from here and still get the same answers. All right, here's a problem, a little bit more complex, and what we're doing is we're multiplying by a scalar and we're subtracting. So just like what we would do with algebra, you're going to want to multiply the scalar to each one of the terms first, and we're going to multiply the 3 to each one of the terms first, and we can get down to this step right here. You don't have to go through that in between. And once we do that, we can go ahead and subtract. So we'll take each element, each corresponding element, and subtract, and you can get to this number, and you can skip this step in between. Take this element and this element and go ahead and subtract and get those answers. Okay, let's go ahead and do another problem for you. I'm multiplying by -6, so I took matrix B and I multiplied everything by -6. Then I took matrix A, multiplied everything by 7, and I went ahead and I found these answers right here, and then I found these answers right here. So these black are for these answers, and then these answers right here, so I'm going to be adding them together. So I'm taking this -72 and this -35, and I'm adding it together, and that'll be -107. Now I'm taking this answer right here, which is -30 right here, and +21, and I'll get the answer -9. And then I just do the same kind of thing here, 12, and then this will be -32, this one will be -10, and this will be 105. And here's how we get the answer. Pause and see what you can do. And here's the answer. Okay, now where do we use these kinds of operations? Well, we can do it by, here's a business example. A desk requires so many short nails and short screws, so many long nails and long screws. And if we want to make 3 desks, and we need this material, then you can take this matrix, multiply it by 3, and we can find out what we need to make the 3 total desks. And for the cabinet, we have a different matrix because it requires different amount of hardware, and so we're going to multiply that by 4 so we can find out the total amount. And when we do this operation, and we're going to distribute and then add, we're going to be able to find the total number of short nails. We're going to be able to find the total number of short screws, the total number of long nails, which is going to be 50, and the total number of long screws, which is going to be 38. So matrices really do have a purpose.